Hey, welcome back to the bench. Good to see you again. Thanks for joining the channel. Hope you're all well. So today on the bench I have a Technics. This is a CD player, a CD disc changer. It's a 5-disc changer. This is the SL-PD888, and it's a mid, would it be mid-90s unit, I believe. I don't know. Yeah, 5-disc CD changer. This one I picked up, and the tag says, so we'll see. I have a feeling it does. I don't know why they would lie to us, but I didn't pay anything for this. It was just in a pile of please take me stuff, so I grabbed it. And you never know. I don't know. I've never been a fan of the 5-disc changers because they're big. They have an overall footprint, huge footprint, because they have to have that big wheel inside. And they're slow and clunky, and they make noise, and when they're working, and I don't know, plastic, a lot of plastic. I'm not a big fan of this 5-disc stuff. I like the single disc players. Another thing about these CD players is they evolved over the years to the point where everything was reduced and scaled down and put on one chip. Like the early CD players, they were very complicated inside. They had huge power supplies because they had a lot of printed circuit boards to power, and they had focus servos, tracking servos, speed servos, and it was all done with discrete components, and there was a lot of stuff going on, and they were interesting to work on, and they were interesting just to look at and figure out how they work. But these, everything's scaled down to a small chip, and they reduced everything inside to make it easier. I don't know, I haven't looked inside this one yet, but we'll have a look inside and see how this one, how it evolved. But let's try it out first. So we got, okay, so it is powered up. We're drawing about 7 watts, okay, and I think if I turn this off, it draws standby power. Okay, so we're drawing about 2.5 watts on standby, 7 watts powered. Okay. Alright, so let's plug in the amplifier as well. Turn on our amplifier, and let's see what goes on here. Yeah, it's pretty sluggish. Typically the failures you're going to see on these is belts that are slipping. So when that happens, your tray won't come out, your tray won't turn, things like that. See, this one's barely making it out. And then if I go, how do I do a next disc? Okay, so we're on disc 1 and 2. Let's do 3 and 4. Next disc, please. How does this work? Disc skip. Oh, there we go. Okay, so that's 4 and 3. 1 and 5. 3 and 2. Okay, so let's we got a CD here. Let's try it out on 1.
Be advised that the decibel values expressed on this is the left channel. My voice should be coming through the left channel only. This is the right channel. My voice should be coming through the right channel only.
Okay, so it is working. It is working well. Main thing is the tray is slow. Well, not the tray is slow. The tray loading is slow. So we might have a weak belt in there. Everything looks good. Seems to be working. Tones. Yeah, so let's open it up and have a look inside and see what we can do for this thing, if anything at all. Seems we have a problem, Houston. Either this is operator error or it's deliberate. or it's a fault. I can't get disc 1 out. Press disc 1, but it won't give me my disc back. It's hidden in there and it won't. Okay, let's try disc 5. No, I didn't want to play. Come on. It's on pause.
Be advised that
Okay.
the decibel values expressed on this CD for test material on it correspond to the peak waveform value of 16 bits or 0 reference. Noise signals on this CD are recorded to correspond to their average.
Okay, I think I know what's going on here. The disc is unloaded from the tray and it's playing. That's why I have access to the other ones, but not the one I want. See, if I go here, this tray is empty. This one's empty, so that yes, I'm confused it. So how do I unload this disc? Okay, stop. Disc 1, open.
Be advised that the decibel values expressed on this.
No, that's not what I want. I want to unload disc 1. No, not play.
Be advised.
Okay, disc 2. Alright. This is awkward. Okay, so we can pick out our disc now. Wow, that's confusing. Alright, screws are out. Tink. Alright, there it is. Quite a bit going on here. A lot of it's covered with the tray mechanism and the turntable. It's interesting that this disc, okay, I see how they're doing it. They raise the disc up to meet this, and the whole mechanism comes up. So this is all power supply here, and it looks like we got some cooked stuff going on. It's pretty warm. I wouldn't be surprised if some of these caps, oh, you can't even see. There's a power supply here. A little tiny transformer, maybe 20 volt amps or more or less. So as far as service goes, all you can really do for this thing is clean the laser, make sure these capacitors are not cooked in the power supply, and make sure we have a good belt. Here's a, looks like a belt right there, which it is. We can remove this, and then that should expose a lot of what we need to do. So let's remove this cover first. I'm just going in blind here. I'm not looking at the service manual yet. How is this hooked in? Clipped. Alright. Here's our disc clamp. It's got a magnet here, which connects with that. So that's what usually clamps your disc. Usually they have a magnet. And you can tell it's a magnet because it sticks. There's our laser. Laser doesn't, it's got some dust on it, but it's not bad. So here we have these 4 holes, and you notice that each position has different coating. So this one has 1 large hole and 3 smaller ones, 1 large hole and 2 holes. So they're all different. So it's reading, this optical pickup is reading the position of this tray. So you can mess it up any old way you want. It's still going to read it and know which position is which. Let's remove this tray and see. Let's remove this tray and see what we need for a belt. All right. This belt seems fine. But what we'll do is we'll take that belt out and clean it. The optocoupler sensor here too, it's sensing the movement of this wheel. This wheel has, let me take this off, I'll show you. It's got a pop this off. Maybe I shouldn't do that. No, I'll leave that alone. I'm looking for the tray loading motor. There we go. Okay, here's the other belt. This belt here is, I don't know, hard to say. Let's take a look at this belt. It's not bad. It just needs cleaning, I think. It's not all mushy and stretchy. It's got lots of tension to it, so it's still a good belt. It's not cracked. Yeah, this says like I just need to clean these belts, so I'll do that off camera. I'll clean the belts, put them back on, and then we'll focus our attention on the laser and anything else we can do with this. I happen to think some of these caps here are going to be dead because it's quite a heat zone here. Here's a heat zone here with these Zener diodes. I like to pull this board out and check it just to make sure that there's no cracked solders, dead caps, or anything like that. So let me clean belts first. Okay, clean the belts. They weren't too bad. They were pretty good actually. So let's try. This is the tray loading belt, and it looks like about a 5.2. Okay, and what square cut belt, and what do we have here? 0.75 thousandths of an inch. Doesn't quite fit into 0.062, but it's 0.075. Okay, so that belt can go back here. This belt, I don't know why they just didn't make the belts the same size. You could have done that easily. This one here is almost a 7. I would say a 7. Well, let's see here. 7.8, 7.9. No, sorry, 6.8, 6.9. Yeah, because we're not quite at 7 yet. Sorry about that. Square cut belt. And I think it's probably the same. 0.075. Yep. And like I said, they weren't too bad. They can go back in. They're good for more service. Okay, to remove the power board, 2 screws on the back panel, and then you have 3 screws holding the transformer in, and the transformer is in a socket, so once you take the 3 screws out, you pull the transformer out, and it sits in this kind of a holder, kind of like this, maybe like this, I don't know, doesn't matter, but this holder goes underneath the board, and then the transformer sits in it, plugs into the socket. And then you need to remove another bracket from the back here. that holds the back side of the board. So there's 2 screws on this, or 1 screw, and then there's 2 screws on the board, and then it's free. And I also unplugged these 2 ribbon cables just so I can flip it over and test. So I have my meter here. This is an ESR meter. I'm mostly concerned about these caps here in this area. So this one here is a 47 at 50. Got about 830 milliohms. 700 milliohms. So these 2 should be the same. So I have a feeling this one is weak or failing. They both might be. And these 2 are 100 at 25 volts, I believe. So they should be the same, 0.69. And let me see if I can get in here. Maybe I can't get in here. Yeah, I should be able to. 0.65, okay. And then the main filter cap is a 2200. There's a cap here in the middle. These 2 power devices that might be cooked as well. So I'm going to lift probably 1, 2, 3, 4, 5, 6, 7, 8. All these caps in this area I might just pull out and test them on my other machine. And if there are any that have failed, I'll replace them. I'm not worried about the other caps. They're out in no man's land here, and they're probably okay. They don't see heat. 5.4.4. What value are those? Those are, that's a 1 microfarad. So that would be a good value for that. This one's a 4.7 microfarad. So this should be okay. This one here is a 470 at 6.3. It should read low. And it does. Okay. So this is the first cap I pulled out. This is the main filter cap. 2200 at 16. And it's way down to 1600 microfarad. And it's got 158 milliohms ESR. This one's had it. It's an Elna cap. It's a high quality cap. And I was looking at a date code of 1997. So it's actually at the end of its life. So I'll replace this one. And I haven't yet pulled the other ones, but I expect to have the same results. Alright, I replaced these 6 caps. They're all failing. They haven't failed yet, but these caps are on the way out. Leaving them in circuit, probably you wouldn't even notice, but when they get bad enough, this is power supply. So what's going to start happening is it's going to start glitching. Maybe it's not going to start properly, things like that. So it's better to get them out now. And if you want to use this machine, get them out now and replace them. Now, pretty much every consumer device I ever look at that has these RCA jacks on a printed circuit board, these are cracked. This is because they take, when you plug in the RCA, it takes stress and it usually cracks the joint. So I always look at them and I always find cracks. So I'm just going to solder these up right now quick. And this is probably the cause of some drop channels. Yeah, it's always good practice to resolder RCAs on the back of any equipment. And then we're done, I think. I think I've done everything I need to do to this board. Resoldered. 6 new caps. I checked a few other caps around here. They're fine, so I left them in place. But this is the heat zone here, so this is where you're going to find your problems. I also found starting of cracks on some of these power transistors, so I reflowed some of the joints on those. So this can go back in. One thing I always do if it has a vacuum fluorescent display is I remove the display and clean it. This is a bunch of screws you remove from the front panel, and then it just flips up, and then you have access. You clean the fog from the inside of the window, and clean the fog off the vacuum tube itself. You can see it picks up quite a bit of dirt. This is a natural attractor of dust because it operates on a little bit of an elevated voltage, so it's statically charged and the dust attracts to it, and it seems to pick up and circulate the air somehow. I don't know how it does it. I don't think it does it through heat. But it's nice to clean it because then you get a nice sharp display. If you ever have an old piece of equipment that has a vacuum fluorescent display, you can see it's all foggy inside and kind of washed out. Take it apart and clean it, and you'll see how it brightens it up and sharpens it. Alright, onto the lens cleaning. So if you have a lens, have a good look at it and take a look at the surface of the lens. If it has any stains or splashes or any kind of looks like liquid that sprayed on it, you're going to need to clean it off with alcohol. But if you look at it and it's clean but it just has dust on it, like specks of dust, then you use a dry cotton swab and with no liquid, and just use it very carefully and wipe off the surface. You can touch the lens. It's not going to go like it's mounted on a suspension because it's designed to float up and down and track with the CD. But give it a good wipe and then inspect it again, and then if it's clean, you're done. If you still see dust and crap on it, then go and give it another wipe. But it looks like I'm done here, so that's all I'm going to do to that and leave that alone. Pretty much done here. The lens cleaning is the last thing I usually do. You can clean this tray. Usually it's got dust on it. I might just do that. I'm going to take this and clean it. We do have grease here on the center, but yeah, there's a lot of lint and dust. I'm going to be right back here. Okay, just cleaning this up. This has got glass cleaner on here, and it's actually taking off quite a bit of brown residue. I don't know what it is, probably dust or maybe it's smoke. But I want to make sure it's clean, and then we can put this thing back together. Feed this in somehow, if it cooperates. And there it is. Okay. The spring and the screw. Okay, now we're ready for a test. Almost forgot, we need to put the disc clamp back on. So let's just drop this into place. Snaps in, and then 2 screws. Okay, now we're ready for power cord. So we're ready to do testing, so let's just load a couple of CDs in. Put one there, throw another one here, and let's turn it on, plug it in. It turns on by itself when you plug it in. It shouldn't do that, but it does. So I'm plugging it in. Okay. Now, I got the lid off and I got some bright lights shining down, so that might muck up the optical sensors and it might do some weird things. Keep that in mind if you're servicing yours and you want to operate it with the lid off. So let's select disc 1. Let's plug it up. Excellent. Next song. Seems to have a long delay between seeking and playing. Well, maybe not. Well, it's working pretty good. There's always a 4 second delay there. Okay, it's working. I don't know if you noticed, as I advanced through the track list, the disc slowed down. That's a constant velocity servo that keeps the disc spinning at the correct speed according to where the laser is on the disc. So the inside, the lower tracks are on the inside, and the outer track is the last songs on the disc. So as it plays through, the disc slows down. I don't know if you noticed that, but let's try disc 3 now. And play this one. This is our test disc.
Be advised that the decibel values, this is the left channel. My voice should be coming through the left channel only. This is the right channel.
Everything's correct that way. Test tones. Ooh, 20 hertz. Okay, I won't play that through. It's going to get annoying. Alright, so everything's working here. Let's put the lid on. Well, there you have it. Quick service for Technics 5-disc CD player. This one was manufactured January 1998. So this is probably about 10 years into the CD revolution that we experienced. So yeah, a lot of this was heavily integrated into chips, a lot of the circuitry. So I know it's not much of a video, but that's it for servicing this one. It didn't have anything wrong with it, actually. Replaced 6 caps, did a little bit of cleaning, and yeah, it's put it back into service. Now, I do also have a couple of older machines. I have an Akai and a Sony, much older than this. I think the older ones are more interesting. They have more circuitry, more problems, aged caps, you know, stuff like that. They have more things wrong with them. This one here is relatively new for 1998, and this one's got a lot of life left in it. So thanks for watching. I know it was a short one, but thanks for watching. Take care, and we'll see you on the next one.